Hello everyone. Today we are going to discuss about instruction set of 8085 microprocessor. Now before going into the today's topic, I assume that everyone has right amount of knowledge about what is called address, what is called data. Keeping that in mind, we should start this topic. We know that there are 74 instructions available in case of 8085 microprocessor. Now what is instruction? That is basically a particular bit pattern designed and developed by the developer of 8085, that is Intel Corporation, where each of these bit pattern associated with certain amount of task. For example, suppose I have written this one 1000000. So it's a 8-bit binary number. Hopefully everyone can see it. It's a 8-bit binary number. Now we can represent the same thing by hexadecimal number, that is 80 hex. The same thing can be represented in this way, that is called add B. So right now you can understand add B means we are talking about A plus B. What is A, what is B? Hopefully you know that. A is the accumulator, B is a general purpose register. So all of these three can perform the same task, that is A plus B. If I write down this one, it can perform A plus B. This hexadecimal code also performs A plus B. This is also add B, can perform A plus B. So what is their basic differences? The developer has selected this particular bit pattern to perform this particular task, that is addition of A plus B. Now being a user, it is very difficult to remember this kind of 8-bit binary bit patterns, at least 74 different bit patterns to perform certain amount of task. So the little bit easier option is that if we represent this binary number by hexadecimal number, then it becomes little bit easier. But still you can find to remember hexadecimal number corresponds to each instruction is a tedious job. So finally they come up with a solution where the instruction is represented by a English-like words. So this English-like words is called mnemonics. So this is the instruction which is written by a English-like words. This is called mnemonics. Mnemonics. P-N-E-M-O-N-I-C-S. Mnemonics. Now when we write down instructions in English-like word, that is called as mnemonics. When we represent instructions in hexadecimal number, then it is called hex code. This is called hex code. And if we can write down instructions in binary number, then that is called machine language. So this is machine language programming, this is hexadecimal programming or hex code programming, this is assembly language programming. Remember, whenever we are writing a program by using mnemonics, that means by using English-like words, then that program is called assembly language programming. So here in this discussion, add B is an instruction. Now today's topic is that we need to understand this kind of instructions available for 8085, because we know the instruction will give us the power to design our own program that can be executed by this processor to perform our own task. So let's get into the topic. Now, depending upon the function, the type of function that can be performed by the instructions, all these 74 instructions can be classified into 5 groups. So remember, we are talking about classification of instructions, and that depends upon the task they perform. Okay, the first one is data transfer or copy operation. That means in this segment we are talking about all those instructions which is basically used for this purpose of data transfer. Second one is arithmetic operation. Third one is logical operation. Fourth one, branching operation, and the last one is machine control operation. Machine control operation. So that means these are the 5 different types of instructions we are talking about. Each of them can be used to perform this particular type of task. Means in a particular program, if I need to transfer data, I should use this kind of instruction. If I need to perform arithmetic operation, I need to use this kind of instructions. Similarly, if I need to perform logical, branching and machine control operations, I need to use these different types of instructions. So that is the classification based upon the function or operation performed by the instructions. Okay. Now start with the first one, that is data transfer operation. Now here one thing we need to remember, the actual term should be data copy operation, not transfer. Why? Now actually what we understand about the term transfer. Transfer means, suppose this is a place A, it contains something, another place is B. So if I transfer this element from A to B, that means A will become empty and B will become occupied by this element. But in case of 8085, this kind of phenomena does not happen. So when we are talking about data transfer operation by 8085, that means the data will be simply copied from A to B. That means the source and the destination, that is A and B, both finally gets same value. So it's not actually transfer, it is basically a copy operation. Okay. Now the question says, okay, data copy operation. Now how many types of data copy operation that we can perform here? So the answer is like this one. Data copy can be done between registers, or it can be done between register and memory, or it can be done between register and memory. Another type is also there. First concentrate only upon these two, data copy or transfer between registers, data transfer between register and memory. Now when I am talking about registers, then I assume that we already have that knowledge about the registers of 8085. So that means we have register A, that is accumulator, and we have some general purpose registers, that is B, C, D, E, H and L. Then we have stack pointer and program counter. Those are 16-bit registers, but these are all 8-bit registers. We know that this is accumulator, part of ALU, arithmetic logic unit, and these 6 are 8-bit general purpose registers. So data can be transferred or copied between any of these registers, So how to perform that one? Take an example. The most easy instruction, probably this one in case of 8085, that is move. The syntax is move R, R. Remember, the second R is source, the first R is destination. Move space RD, RS. So that means data will be copied from RS register to RD register. Means the content of this register will be copied into this register. Clear? So take an example of this one. What can be the example of this one? Anything. Suppose move RD, maybe accumulator, RS can be anyone, B, C, D, E, H, L, anyone. So that means the content of B register will be copied into A. And remember, after this operation, B and A both gets the same value, because the content of B has been copied into A. So that means the value that was available within B is also available within B right now. but its another copy or a replica of that particular value is available within accumulator. Similarly, the reverse one we can write down. Move suppose C comma A. That means the content of the accumulator, content of this accumulator is copied into register C. So that is the example of data moving or data transfer between registers. Now we have another example, that is between register and memory. The very easier one or the easiest one is this one, by using move instruction. Simple. Move register comma M, and the reverse one, that is move M comma R. In the first case, we can understand move RM means data will be copied from memory to register. In the second case, data will be copied from register to memory. Now you might be thinking that we have studied about all the registers starting from accumulator, then B, C, D, E, H, L, stack pointer, program counter, but we have not studied anything about M register. So remember, whenever we are using M as an operand, what is operand? First we need to know. Every instruction has two parts. One is called opcode, another one is called operand. Take an example of this one. Sorry, add we have not discussed till now. Take the previous one, that is move RD comma RS. This is known to us. So that is the instruction that we have written in English like words. That means it is called mnemonics. Now each instruction has two parts. First one is move, second one is RD comma RS. This move stands for the operation that we want to perform here. That is called opcode. Opcode. And this operation will be performed upon these elements or upon these registers. So they are called operand. So I am repeating it once again. The mnemonics has normally two parts, opcode and operand. Opcode defines the task that I want to perform, the task that we want to perform. Operand means on which this operation will be performed. So here the operation is moving operation. So opcode is move, on which we want to perform the moving operation, that is RD comma RS. Clear? So I am saying that whenever the operand has M as an, when the operand is M itself, then M stands for memory. Then M stands for memory only. So now the question is, if the content of memory should be transferred into R, take an example, then it will be easy to understand. Suppose the example of the first one is, example of this one is move B comma M. What does it mean? The content of the memory should be copied into register B. Now the question is, which memory location I am talking about? Which memory location? Because we know in case of 8085, it can access maximum 64 KB of memory. I assume that this information is known to us. That is the maximum size of memory that 8085 can access. That means the memory space has 65,536 number of registers. So that is the number of memory registers available for 8085. So out of this large number of registers, which particular register we are talking about? Which particular register we are talking about? So that has to be identified by somehow. Remember, whenever we are using M as an operand, then the corresponding memory address will be given by HL register pair only. That is true for every time. Whenever we are taking M as an operand, then the corresponding memory location should be given by the content of HL register pair. So for example, we have written move B comma M. At the same time, the content of HL register pair, hopefully everyone knows the programming model. This is A, this is F, this is B, C, D, E, H and L, then stack pointer, then program counter. That is the programming model. So whenever we are discussing about instructions, we need to remember this particular programming model. That model basically represents 8085 when you are talking about instructions. So assume HL register pair contains a data like this one, 20 hex, 00 hex. So that is already available within HL register pair. After that, we have executed this one, move B comma M. That means data from memory location 200 hex, the content of HL register pair is now 2000 hex. Remember, whatever HL register pair contains is basically a data. It's basically a data, 16-bit data. But this instruction will use this data as an address. I am repeating it once again. HL basically contains data, but when I am writing this instruction, or when we are executing this instruction takes this data as an address, and from this memory address whatever 8-bit data is available would be copied into register B. Clear? And the reverse one, that is the data transfer between memory to register. If I want to transfer data from register to memory, then we need to use this instruction, move M comma R. That means the content of register R will be moved into memory. So once again the question arises, at which memory location I want to store the data of register R? The answer is the content will be given by HL register pair. Clear? So that is a very easy way to transfer data between register to memory and from memory to register. Okay. Now except this, we have plenty other options to be performed. We will gradually get into that. Okay. So the first one we should explain here is LDA, and we have another one that is called STA. LDA and STA, these are very important and popular. LDA means load accumulator direct. STA means store accumulator direct. Now, what is the meaning of loading and storing? What is the meaning of loading and storing? Try to remember this diagram. Assume this is the microprocessor and assume this is the memory. This is memory. Okay. Loading operation means data will transfer from memory to processor. That is called loading. That is called loading operation. And when data transfers from processor to memory, then that is called store or storing operation. So loading means data is traveling from memory to processor. Storing means data is traveling from processor to memory. Clear? So load accumulator direct, that means we want to load accumulator. Accumulator is here. We want to load accumulator directly from where? From memory. Means memory location is required. So the syntax is LDA space 16-bit address. Similarly, STA means store accumulator direct. Where I want to store? On a particular memory location. So the operand here is 16-bit address. Hopefully This is understandable. I'm repeating it once again. LDA means load accumulator direct. Accumulator is here. We want to load accumulator direct from memory. So from memory means from which location? So this location. Store accumulator direct means I want to store the content of the accumulator directly into memory. So obviously question arises, at which memory location I want to store the content of accumulator? The answer is this one. The answer is this one. So a typical example can be taken in this way. That is LDA 200 hex. That means assume this is the memory we are talking about. We know that the starting location of the memory is 0000 hex. The end location is FFFF hex. Hopefully you know this one. In between them, maybe this is the location whose corresponding address is 2000 hex. So this memory location contains a data. Data can be anything, any 8-bit data starting from 00 to FF. So suppose the data is 2F. So that is the content of the memory location 2000 hex. In this condition, if I execute this instruction, that is LDA 2000 hex, then what will happen? The accumulator will directly get this value, that is 2fx. Similarly, if I write down this one, STA 3000 hex, what does it mean? I want to store the content of the accumulator to this memory location. So once again take this example, take this picture. So if this is 2000 hex, maybe this one represents the location 3000 hex. So already accumulator is loaded with this value, that is 2fx. Already accumulator is loaded with this particular value. Now if I execute STA 3000 hex, that means the content of this accumulator will be directly stored to this location. That means this 2fx will be copied here. That is 2f hex is here. So that is LDA and STA. So that is the method of direct loading and storing. Now there is an indirect method is there. The corresponding instruction for that is LDAX. For indirect storing method, we have STAX, stacks, LDAX. Okay. Now LDAX means load accumulator indirectly. Load accumulator indirectly. Now the question is where? The answer of this where will be given by a register pair. So that is why the operand here is register pair. Similarly, STAX, stacks, means store accumulator indirectly. So once again question arises, where I want to store the content of the accumulator? The answer is register pair. That means the location of loading and storing the content of accumulator will be given by a register pair. That is why this is called indirect method of loading and indirect method of storing. Take an example. Suppose I have written LDAX D, because we know D is a register pair, DE register pair, BC register pair. So if I want to understand this one, once again I need to draw the programming model. So this is accumulator, this is F, then we have BC, then we have DE, then we have HL. Now assume the content of the accumulator is 2F hex and DE register pair contains a data that can be this one, 30 hex, 01 hex. Assume that is the condition. At this condition we have executed LDAXD. Then what will happen? that will be easy to understand. STIX. I have written this one, stacks D. I have written stacks D. So that is the condition. Then I want to execute stacks D. Stacks D means we are talking about storing operation indirect method. Storing operation of indirect method. So that means the content of this accumulator 2fx will be stored to the location denoted by DE register pair. So that means if this is the memory and this is suppose 3000 hex location, the next one should be 3001 hex. If that is the memory, then after executing stacks D, what will happen? The content of this accumulator, that is 2fx, will be directly copied into 3001 because this memory location has been denoted by DE register pair. So that is why that is called indirect method of storing. So in case of loading, what will happen? The reverse one. Suppose take another memory location, that is 400 hex. That memory location holds a data. Suppose the data is 23 hex. In this condition, I have written LDAXD. So what is my target? I want to get this value, that is 23 hex, which is available at a memory location 4000 hex into accumulator. So to perform that one, first I need to load DE register pair with this value, that is 40 hex and 00 hex. So if that is the scenario and then I have executed LDAX, then what will happen? 4000 hex, that is the location denoted by DE register pair, From this location, the 8-bit value that we are getting will be directly copied into accumulator. That means now accumulator will get this value, that is 23 hex. So that is called indirect method of loading and storing. Now another information I should tell you here, if you find X in any mnemonics, you should understand that the operand will be a register pair. There is an exception. Exception is that if X is the starting letter of any mnemonics, then operand might not be register pair. But instead of this first location, if anywhere X is available, then obviously the operand has to be a register pair. Okay. Now another topic we need to understand here, that is, suppose this is the programming model that we are talking about every time. I am not drawing it properly. This is AF, BC, DE, HL, then stack pointer and program counter is there. So already we know how to copy data from each of these register. That is possible. Now if someone says, sir, I directly want to load, or directly want to, you should have to remember this term, directly want to load any of this register with a value. Suppose I want to put 02 here, I want to put 03 here. Can I do that? That is possible. This kind of data is called immediate data. This data is called immediate data. For that, the instruction is MVI, move immediate data. Then question arises, where and what data? Suppose I want to perform this one. I want to put 03 as an immediate data into register B. Then what should my syntax? MVI space B, 03 hex. So that means this 03 will be directly copied into register B. Clear? Suppose I want to perform this one. I want to get 02 as an immediate data into register E. Then I should write down this one, MVI E, comma 02 hex. 02 hex. So remember, if any instruction has I within the mnemonics or within the opcode, then this I stands for immediate data. There is an exception. If I is the beginning letter, then it does not represent immediate data. But if it is anywhere except the starting location, then I represents immediate data. Means if I is here, it does not represent immediate data. Except this location, if anywhere I is present within the opcode, then I represent immediate data. Okay. Then we have another instructions, that is LHLD and SHLD. LHLD, from the words you probably can understand, load HL. Sorry, there is a technical problem there, so it should start once again. We are talking about LHLD and SHLD. LHLD means load HL register pair directly. So the question arises, from where I want to load my HL register pair. So answer is a 16-bit address. Similarly, if I say SHLD means store HL register pair directly. Once again question arises, at which location I want to store. So that means the operand is a 16-bit address. Now here a little bit twist is there. What is that? Take an example, LHLD space 3000 hex. That means we want to load HL register pair directly from this location. So that is the location we are talking about. Now we know each memory location can have only 1 byte of information. Only 1 byte of information means 8 bit of information. So how a register pair can have only 1 byte of information? Because to load HL register pair I need at least 2 byte of information. But from this location I can get only 1 byte of information. So that means from where I will get another byte of information. So the answer is, in case of LHLD and SHLD, though the operand is a particular memory location, but the instruction will use 2 consecutive memory locations. I am repeating it once again. In case of LHLD and SHLD, though the operand is a 16-bit address, but we can found that processor requires 2 consecutive memory locations starting from this one. That means which one is denoted by the instruction itself. Starting from this location, it will take 2 consecutive memory location. From 2 consecutive memory location, it will get 2 8-bit datas. That 2 8-bit datas will be copied into HL register pair. So assume 3000 and 3001 takes these values, 2 3 hex and 4 5 hex. In this condition, if I execute LHLD 3000 hex, then what will happen? The content of 3000 hex will be copied into L, and content of next memory location will be copied into H. That means L will get 2 3 hex and H will get 4 5 hex. The reverse one is SHLD. Suppose I have written SHLD 3002 hex. Means I want to store the content of HL register pair to this location. Now one second problem arises. If I want to store HL register pair, that means I want to store 16 bit of information. But on a particular memory location, I can store only 8 bit of information. So what is the solution? Solution is that once again, when we execute this instruction, processor can understand that it can access, or it has to access, 2 consecutive memory locations starting from 3002. So in our example, the next one is 3002 hex. This is 3003 hex. So though the instruction has only this operand 3002 hex, but instruction will actually access 2 consecutive memory locations. So now H has 45, 23 has 23 is within the L. So in this condition, if I execute SHLD 3002, then what will happen? The content of L will be copied here, that is 23 will come here, and 45 will come here. 45 will come here. So that is the method of LHLD and SHLD. Then another important instruction is LXI. 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 Register pair, comma, 16-bit address. So already I have said, if an instruction has X anywhere except the starting letter, then X stands for, or X indicates register pair. So you can find the operand is a register pair. If we have anywhere I within the opcode, then it represents immediate data. Immediate data. So take an example here, then you can understand. So example is LXI H, 2000 hex. What does it mean? Load HL register pair with an immediate data, this one. Don't get confused. This 2000 hex looks like a address, but when I have used 2000 hex as an operand of this instruction LXI, then this becomes an immediate data, not address. Then it becomes immediate data. So though it looks like a 16-bit address, but as the instruction is LXI, means loading a register pair with immediate data, then this 16-bit number available within the operand has to be an immediate data. So what will happen actually here? Assume this is the HL register pair we are talking about. This is H and L, and if we execute LXI H, 2000 hex, then what will happen? 20 will come here, 00 will come here. Clear? Now remember, register pair, I have taken the example of register pair as H. It can be DE register pair also, means LXI D you can write down, LXI B you can write down. Okay. The next instruction that I should mention here is XCHG. That is XCHG. Remember, I have said if the instruction has X anywhere within the opcode except the starting location, then X represent register pair. But here X is available at the beginning of the opcode. So obviously this X does not represent register pair. So what is this one? This talks about exchange. This talks about exchange. XCHG, and that is the whole syntax. You don't need to write down any operand here. XCHG means exchange the content of HL register pair with DE register pair. Exchange the content of, I'm writing here, the content of HL register pair will be exchanged with DE register pair. And that's really interesting. Suppose this is the programming model we are talking about. So the last two is HL and DE. Suppose here we have 01, 02, 03 and 04. These are the data available in DE and HL registers. Then I have executed XCHG. Then what will happen? They will make a change. After change, what will happen? D should get the value of H. That means it will be 03. This one will be 01. This one will be 04. This one will be 02. They will make an interchange between them. And remember, this instruction takes the operand by default as HL and D register pairs only. I cannot make exchange between HL register pair and BC register pair. That is not possible. Okay. And similarly, in case of SHLD and LHLD, remember that works only with HL register pair. Okay. So these are the very few instructions that is useful for data transfer operation. Hopefully you can understand it, and if you have any query, you can put down at the comment section. I will try to give the answer if the answer is known to me. Thanks for watching. Thank you.